For more than 2 decades, the Lockheed Martin F-22 Raptor has been regarded as one of the most dominant air superiority fighters ever built. Designed during the final years of the Cold War and introduced in the mid-2000s, the aircraft combined stealth technology, supercruise capability, extreme maneuverability, and advanced sensor fusion into a platform that many military analysts still consider unmatched in pure air-to-air combat. But the nature of modern warfare is changing rapidly. As China expands its military reach across the Indo-Pacific and Russia continues developing advanced combat aircraft, the United States is facing growing pressure to keep the F-22 relevant in an increasingly contested battlespace. That pressure has now given rise to what defense observers are informally calling Raptor 2.0, a heavily upgraded vision of the legendary stealth fighter built for the next generation of conflict. Recent sightings, concept models, and industry presentations suggest that the F-22 may be entering the most significant modernization phase in its operational history. Interest in the so-called Raptor 2.0 intensified after scale models and updated visual concepts appeared during defense exhibitions connected to the U.S. Air Force and aerospace industry events. The redesigned aircraft featured several unusual additions not commonly associated with the standard F-22 configuration. Among the most noticeable changes were stealth-shaped external fuel tanks and underwing infrared search and track pods, commonly known as IRST systems. To aviation enthusiasts, these details immediately stood out. Traditional external fuel tanks are normally avoided on stealth fighters because they dramatically increase radar visibility. The newly observed tanks, however, appear to use angular stealth geometry intended to minimize radar reflections while still extending the aircraft's combat range. That detail alone reveals a great deal about how American air combat doctrine is evolving. Despite its reputation, the F-22 has one major weakness in modern strategic scenarios: range. The aircraft was originally optimized for high-intensity air combat in regions closer to friendly bases, particularly during an era when the U.S. military focused heavily on Europe and the Middle East. But a potential future conflict in the Indo-Pacific presents an entirely different challenge. Distances across the Pacific Ocean are enormous. American fighters may need to operate thousands of kilometers away from major bases while facing increasingly advanced anti-access and area denial systems developed by China. In that environment, endurance and operational range become just as important as stealth and maneuverability. The stealth fuel tank concept appears to be a direct response to this problem. Rather than sacrificing low observability for additional fuel capacity, the upgraded design attempts to preserve the aircraft's stealth characteristics while significantly extending mission endurance. For long-range operations over the Pacific, that capability could become critical. Another major feature associated with the upgraded Raptor is the addition of an IRST system. Modern air combat is becoming increasingly difficult for radar-dependent aircraft. Advanced stealth fighters are specifically designed to reduce radar signatures, making them harder to detect using conventional methods. IRST systems offer an alternative approach. Instead of relying on radar emissions, these sensors passively track heat signatures generated by aircraft engines and aerodynamic friction. That allows a fighter to search for enemy aircraft without revealing its own position. For an aircraft like the F-22, which was built around stealth and first-look, first-shot tactics, passive tracking capability is an enormous advantage. Analysts believe the upgraded IRST package could significantly improve the Raptor's ability to detect next-generation threats such as the Chengdu J-20 and Sukhoi Su-57. Combined with advanced sensor fusion software, the aircraft would be able to merge radar data, infrared tracking, electronic surveillance, and battlefield network information into a single tactical picture for the pilot. Many of the rumored F-22 upgrades appear closely connected to America's strategic pivot toward the Indo-Pacific. Unlike previous conflicts, A future war in the region would likely involve extremely long-range missions, distributed air operations, and constant threats from advanced missile systems. Aircraft would need to travel farther, remain undetected longer, and share information seamlessly across multiple combat domains. The upgraded Raptor seems tailored for exactly that environment. Defense analysts believe the aircraft may also receive improvements to electronic warfare systems, secure communications, artificial intelligence-assisted mission processing, and integration into the Pentagon's evolving Joint All-Domain Command and Control Network. In other words, the F-22 is no longer being viewed as just a standalone stealth fighter. It is increasingly becoming part of a larger, connected combat ecosystem. One of the less visible but potentially most important aspects of the modernization effort involves software architecture. Earlier generations of military aircraft often relied on closed and highly specialized systems that were difficult to upgrade quickly. New hardware or software integration could take years. Modern military aviation is shifting toward open architecture systems instead. This allows new sensors, software packages, electronic warfare tools, and even AI-assisted technologies to be integrated much faster than before. Lockheed Martin has repeatedly emphasized the importance of digital modernization for keeping legacy stealth platforms competitive in the future battle space. For the F-22, that transition could dramatically extend its operational lifespan. Rather than becoming obsolete, the aircraft may continue evolving through continuous software and systems upgrades, similar to how modern smartphones receive new capabilities through updates. The modernization of the F-22 does not mean the U.S. Air Force has abandoned sixth-generation fighter development. Programs connected to Next-Generation Air Dominance, or NGAD, are still moving forward and are expected to eventually replace the F-22 in frontline service. Early reports suggest the future platform could feature advanced stealth shaping, collaborative combat drones, adaptive engines, and next-generation electronic warfare systems. But building an entirely new air dominance fighter is an enormously expensive and time-consuming process. That reality makes Raptor 2.0 strategically important. Rather than waiting for NGAD to fully mature, the Air Force appears determined to keep the F-22 ahead of emerging threats during the transition period. In many ways, the upgraded Raptor serves as a bridge between 5th-generation and 6th-generation air combat. Even today, the F-22 remains one of the most respected combat aircraft ever produced. Its combination of stealth, speed, agility, and situational awareness still places it among the deadliest fighters in existence. While newer competitors continue to emerge, very few aircraft have demonstrated the same balance of survivability and air superiority performance. That is precisely why the United States is investing so heavily in keeping the platform alive. The rise of Raptor 2.0 suggests the story of the F-22 is far from over. Instead of fading into obsolescence, the aircraft may be entering a new phase of evolution, one shaped by long-range Pacific warfare, network-centric combat, and the realities of next-generation aerial conflict. And if the rumored upgrades become operational, the world may soon witness the most capable version of the Raptor ever built.